Mr. Harris here, and welcome to a new video. In this video, we're going to continue talking about the calculation of moles, and primarily we'll be using the second equation that we learned, the number of moles of particles, which is equal to the number of particles divided by Avogadro's constant, which is 6.02 times 10 to the power 23. So let's get into it. Calculate the number of oxygen atoms. So here you can see this question is asking us to find the number of particles, in other words. In 12.4 grams of H2CO3. Now, H2CO3 is carbonic acid. So first off, in order for us to find the number of particles, that is the number of oxygen atoms, we need to find the number of moles of oxygen atoms. And in order to do that, we will need to first find the number of moles of carbonic acid. Okay, so here, let's do that first. Number of moles of carbonic acid. Maybe I'll just write the chemical formula, H2CO3. Now this would be equal to number of moles, which is the first equation we learned. It is equal to the mass over molar mass. The mass here, it's provided. It's 12.4 divided by the molar mass. Now remember, the molar mass is just all of the relative atomic masses combined. So here I have, you can see I have two hydrogen atoms. So the relative atomic mass of hydrogen is 1 times the two hydrogen atoms. Remember, it's adding all of them together, so I add a plus sign. I have only one carbon atom here, so plus 12. And finally, I have 3 oxygen atoms. So relative atomic mass of oxygen is 16 times by the 3 atoms that you see there. And you take out your calculator and calculate this. This is 12.4 divided by all of this, add them up, take out your calculator. This is 62. Okay. And then finally, to get your answer, this is going to be 12.4 over 62, sorry. You get 0.2 mole. Okay. Now, as I said earlier, you don't really need to write the unit here, but I tend to write the units so that we get into the habit of writing the unit every single time. Okay, moving on. Now, a lot of you will start to think of, oh, we have found a number of moles of H2CO3. Now we can apply the second equation. Now let us recall what the second equation was. I'll write it on the top right here. The second equation we learned was the number of moles of particles is equal to the number of particles over Avogadro's constant, or Avogadro's number, which is 6.02 times 10 to the power 23. Now, a lot of you would immediately think that this number of moles of particles is what you just found here, the number of moles of H2CO3. Now here, this is where a lot of you will fall into the trap. This number of moles of particles is what your question wants you. Now the particles here, what are we talking about in the question? Do you see in the question we're talking about oxygen atoms? So here, actually, I would prefer you to think of, you're supposed to find the number of moles of oxygen atoms. But we have just found the number of moles of the entire molecule, which is carbonic acid. So I could also change it here. This is the number of oxygen atoms. That's what you're trying to find. So here, now we need to first actually find the number of moles of oxygen atoms first. And how do we do that? Remember in the first video, that is where I introduced how you can find the number of oxygen atoms. You take the number for the whole molecule, the number of moles of the whole molecule, which here it's 0.2, and you times it by whatever the number of atoms there are. So here you can see that we have 3 oxygen atoms in carbonic acid. So you times it by 3. And here, thus the number of moles is 0.6. Okay. Now that you get the number of moles of oxygen at 0.6, now we can find our answer. So let me move this down so we have more space. Now we can apply this equation here. So I just need to move sort of everything to the left and right hand side. So I'll just do it for you. So 0.6 would be equal, that is the number of moles of oxygen atoms. So maybe I'll color coordinate for you. The number of moles of oxygen atoms, this is 0.6. Is it equal to the number of oxygen atoms? That's what the question is asking us to find, divided by Avogadro's number, 6.02 times 10 to the power 23. So here, this one, number of oxygen atoms, this is this one here, and maybe I'll use this color, 6.02 times 10 to the power 23. I just added back here. Now you just need to basically move around the numbers, number of oxygen atoms. This would be equal to 0.6 times by the Avogadro's number. Then you can take out your calculator and you'll get the answer is, again, you can leave it as three significant figures, sorry. So you will get 3.61 times 10 to the power 23. Okay, are there any units? Yeah, you can just add the word atoms to it, oxygen atoms. That would be the unit for this. But it's not, as I said, it's not necessary. It's just if you're interested, then you can add it. But technically speaking, this is already enough. So there you go. This is how you find the number of particles using the first equation, moles, number of moles equal mass over molar mass, and then applying the second equation. Okay, now let's do part B. It says now, it's the same question. Instead, we are trying to find the number of hydrogen atoms this time. So if you didn't do this part A question, then I would suggest you again to find the number of moles of carbonic acid. So I'm just going to copy that down first. We already found it in part A, the number of moles of carbonic acid. So here, let's see what it was again. It was 0.2 moles. So I'll just copy back down here. It was 0.2 moles. And then again, this time, remember for the equation, we are now supposed to find the number of, instead of oxygen atoms, now we're finding the number of moles of hydrogen atoms. So remember, this is the number of moles of hydrogen atom. The particle we're talking about now is hydrogen atom. So I cannot use this number of moles directly. I would need to find the number of moles of hydrogen atoms now. Number of moles of hydrogen atoms. So again, you're going to take back the number of moles of the carbonic acid and times it by whatever the number of hydrogen atoms is in carbonic acid. So here you can see that there are 2 hydrogen atoms present there. So you times it by 2. And there you go, 0.2 times 2, very easy, 0.4 mole. Okay, now again, apply our same equation here. Number of moles of hydrogen atoms is equal to the number of hydrogen atoms divided by L. So I'll do the same thing. So you get 0.4 is equal to number of hydrogen atoms divided by 6.02 times by 10 to the power 23. And therefore your answer would be number of hydrogen atoms is equal to 0.4 times 6.02 times 10 to the power 23. And the answer you get should be 0.4 times 0. 2.41 times 10 to the power 23. Now, 3 significant figures. Again, as I said, in chemistry, you do not need to specify it's 3 significant figures. It's already assumed that your answer is going to be in 3 significant figures. So this is how you apply the 2 equations together.